Alright, this is section 8.1. Now we have two assignments in here. 8.1 functions dealing with properties of functions. And then there's another 8.1 functions assignment that's called graphs of functions. Right? So this assignment talks about properties only of functions. The second assignment comes out of the same section, but it talks about graphs of functions. Now, since they both come out of the same section, the examples in this section will be the same. So I'm only going to go through the examples for this section once in this video. The next video I'll go straight to the similar questions. Alright, so first, before we talk about functions, we have to talk about relation. Now, what is a relation? A relation is simply relating anything to anything else. I can relate this pencil to this whiteout tape. I can relate this piece of paper to my house. I can relate anything to anything else. That's called a relation. Now, if you want a relation to be a function, there's a little bit more involved. The function requires that for a given input, you know exactly what your output is, and it's predictable. Meaning, for a given input, you only have one and only one output. Alright? So, if you input $1, for example, at McDonald's, and you choose something from the dollar menu, it's not predictable as to which item you're going to pick. There's multiple choices there. Now, if you went into McDonald's and they had the dollar menu and there was only one item on that menu, that would mean input $1, you get the one item, and that's a predictable function. Let's say you have a soda machine. It's got a bunch of different sodas in there, and they all sell for $2.50. Well, input $2.50 and you have many choices for the output. That's not a function. Now, if you go to the soda machine and you've got different values for each soda, like a Coke is 2, a Pepsi is $2.50, and Fanta is 3. Now you input a certain dollar amount and you know which one you're going to be picking. So for a given dollar amount, it associates with only one specific soda. Alright? Now, when you talk about functions, you can talk about points on a graph. An ordered pair is made up of x's and y's, and x is your input value and y is your output value for that input value. So if you input 5, you get an output of 35. You input 8, you get an output of 56 because the function is multiplied by 7. This function says take the input and multiply it by 7. So 5 times 7 is 35, 8 times 7 is 56. So that's your function. Now here's a formal definition of the function y equals f of x. You can write it that way. And x is your input and y is your output. Those are your x's and y's for your ordered pair, or points. Alright? So you input 4 and the output is 28. So, and the way you read that is you say f of 4 equals 28. Okay? F of 4, that's the way you read that. Alright? So in this one, you've got a function where whatever you throw in there, you're going to add 5 to it. So you throw a 4 in there, you add 5 to it, and it kicks out a 9. Okay? You throw in a 0, it adds 5, and you throw out a 5. Doesn't matter what it is, you're going to throw something in, you're going to add 5, and that's what the function does. Now there's many ways that you can talk about representation of a function. You can write it out in words. Multiply the input x in yards by 3 to obtain the output y in feet. For example, if you want to convert yards to feet, 1 yard equals 3 feet, if you don't know that. Okay, so the numeric representation is a table, and this is a table of representation that 1 foot, 1 yard equals 3 feet, 2 yards equals 6 feet, 3 yards equals 9 feet, and so on. Alright, symbolic representation is another word for the formula, y equals 3x. Or you can say f of x equals 3x. Alright, then there's the graphical approach. You draw a graph, and the graph is made up of individual points, and each one of these points gives you an answer to the function. You input 1, you output 3. Input 2, you output 6. And so those points on your graph make up the actual graph, and this is what your graph looks like here. Input 1, output 3, input 2, output 6, input 3, output 9. So 1, 3, 2, 6, 3, 9, and so on. And so you can draw a straight line there, and that shows you that not only at 1, 2, 3, 4, and 5 there are answers, but at 0.5 and 2.1 and 3.7 you'll also get an answer. So there's many answers to these questions. And so if you input 1, your output is 3. You go up and down until you hit the graph, and then you go left to right until you see what the y coordinate is. Okay? So if you input A, your output is B. So f of A and f of A are the same thing as A, B, because B equals f of A. Now you can also draw a graph using a diagram here. And so input 1, output 3, input 2, output 6, input 3, output 9. All right? Now if you take these functions and you let the input be the guys and input be the girls, and this function shows who they're dating, if guys are monogamous, it's a function. If guys are dating more than one girl, it is not a function. Right? So notice this one is a function even though each guy is dating the same girl. We don't care. We don't care how many guys the girls date. We just care how many girls the guys date. Guys, you have to date only one girl. Okay? Notice this guy is dating 2 girls. It's not a function. Or think back to predictability. Remember I said if you input something, you have to know exactly what the output is. Input 1, you output 4. Input 2, output 4. Input 3, output 5. Input 1, output 4, sure. Input 2, well, you don't know what answer it's going to give you. So that one is not a function for that reason. Alright? And now if you want to evaluate a function, okay, I recommend you do something that I created it an idea I came up with myself. I call it f of blank. Okay? Wherever you see x, you put a blank set of parentheses. So if f of x equals 3x minus 7, you write f of blank equals 3 blank minus 7. And for the second one, f of blank equals blank over blank plus 2. Okay? And you can do the same thing for the third one. So now, no matter what number or value they give you, you plug it in there everywhere you see a blank set of parentheses, and then you just crunch it down and figure out your answer. So on this one, f of x equals 3x minus 7, and they say plug in minus 2. So f of minus 2 equals 3 times minus 2 minus 7, and you multiply it out and you get your answer. 0.5 in there for x, and you so put 0.5, 0.5, and you get this, and you simplify it down using your calculator there. Now plug in a 10 there, and so it's the square root of 10 minus 1, which is ends up giving you just 3. Alright. Now here they talk about sales tax. If you want to calculate the sales tax, you multiply the number of x dollars by 0.07, and that will tell you what the tax is on the item you're buying. Okay? And then you can do numerical by a table, you can do a formula, you can draw a graph, and you can draw a diagram. So here's the table. $1 you pay 7 cents, $2 you pay 14 cents, $3 you pay 21 cents. So 1 is to 0.07, 2 is to 0.114, 3 is to 0.21, and so on. And then you got the same thing going on here. Alright. So somebody has crutches, and one thing you can do to get a very quick estimation of the proper adjustment for the crutches based on your height is use this formula of 0.72t plus 2. L of t equals 0.72t plus 2, where t is your height in inches. So someone is 60 inches tall, that's 5 feet tall. Okay? So you plug in 60 in there, and so you say 0.72 times 60 plus 2, and you get 45.2. So adjust your crutches to 45.2 inches. All right. From the formula, we can see that each 1 inch increase increases it by 0.72. For example, if you look at what the height of the crutches would be for 71 inches versus the height for 70 inches, you get these two numbers and you subtract and you get 0.72. It's not a coincidence that it's the same as this number here. Same as that number here. That's your slope. That's the rate of change. So as t goes up by 1, you add another 0.72 to your answer. Okay? Then they talk about representation for a function. This looks like it's x squared, or it is x squared minus 1. So symbolically you write x squared minus 1. Okay? The function says square the input x and subtract 1 to obtain the output y. So f of x equals x squared subtract 1. Numerically, you just plug in different numbers. They want to know for, I think, for -2 all the way up to +2. So you can plug in -2 into the function, you get an answer, and same thing for all the other numbers. And if you make a table of this, you can answer that question. So how do you do a table on this sort of thing? You hit y equals, okay, hit y equals and type in x hat 2. You got an arrow to the right to get out of the exponent and then subtract 1. So I hit the x key here. I hit the x key here. I hit the hat key. That tells me I'm about to hit an exponent, and I type in 2. Then I have to arrow to the right to get out of the exponent, and then I subtract 1. Okay? Subtract 1. Okay? Now if I want to see a good graph of that, I can hit zoom 6. That gives me a 10 by 10 window, and that looks just like that guy right there. Now if you want to see a table, you can hit second window, and you can start your table. Typically you start at 0 and you go up by 1. So 0, 1, and leave those last two on auto. Okay, now hit second graph, and that gives you a table. And look at all those table of values. If you want the negative numbers, you can arrow up and get the negative numbers as well. Alright. So again, you got an input and you got an output, and all of your inputs are your domain, all of your outputs are the range. So if they give you a set of values for a function, you can just look at the x values and that's your domain, look at the y values and that's your range. Alright. Now this one says compute the average income, and so they say f of n equals 21,000 something, f of h equals 31,000 something, f of b equals 57,000 something, f of m equals 70,000 something, where N is no diploma, H is high school, B is bachelor's, M is master's degree. So notice the higher your education is, the higher your average salary is. So write F as a set of ordered pairs. You just list N, comma, whatever 21,000 number is. Don't put commas in the 21,000 number. Leave it without a comma, because the only comma that you want to put in points is in between the X value and the Y value. Then you put the H and then its salary, B and its salary, M and its salary. Now the domain is simply the NH, M, and V. And the range is simply the salaries. Okay? Now it says discuss the relationship between education and income. Well, education pays. The greater the education, the greater the annual salary. Okay? Now here it says find the domain and range graphically. Now what you can do is what I call the pancake approach. You can squish it onto the x-axis. Squish this thing onto the x-axis like a pancake, and wherever it sticks to the x-axis is your domain. So if all of this comes down, it will hit between -3 and +3. And now if you squish it onto the y-axis, it will hit from 0 up to 3. And so that's what your domain and range are. Your domain for A is -3 to 3, and your range is 0 to 3. Okay, so you can show it as an inequality, you can show it as an interval notation, either way. Now this one, when you squish it onto the x-axis, it hits everywhere, because this is going to the left, up and up and up, and it just keeps going further left, so it goes to minus infinity. This is going to the right, and it's going off to the right to positive infinity, so your domain is every number you can think of, minus infinity to infinity. Now your range is different. When you squish it onto the y-axis, you hit -3 or above. And so that's your range is y greater than or equal to -3. Alright. Now this one says find the domain of the function. Okay? Well, you only have to worry about even roots, like square root, fourth root, sixth root, and fractions with a denominator of the letter. Okay, so these two are specific problems that you have to worry about. Otherwise, if you don't have the fraction and you don't have the square root, just say all real numbers. Okay, you don't even have to care what it looks like. It's a line, by the way, but you don't care about that. You just care that it doesn't have a denominator with a variable in it or a square root. It doesn't, so you just say all real numbers. Now b, you're worrying about dividing by 0. So set x minus 2 equal to 0 and you get x equals 2. So that means x cannot equal 2, because if you put a 2 in here, you're dividing by 0, and we can't do that in mathematics. You can't divide by 2. So you can say all real numbers except 2, or you can say x not equal to 2, or you can say minus infinity to 2 union 2 to infinity. Okay, so that's your way of saying minus infinity to infinity except 2. That union symbol, it's not a capital U, it's a mathematical symbol, and typically when you want to type that into your answer on your computer, when you click on the answer box, it typically off to the right gives you a template that you can choose for union. That's what this is, union. And then the opposite one is intersection. Looks like an upside down U. Alright. Now they say determine whether a set of ordered pairs is a function. So all you care about is the x values. Look at the x values and ask if any of them repeat. IBM, HP, Oracle, Apple, Microsoft. Any of them repeat? No. Then it's a function. And that's it. Okay? Determine whether the table of values represents a function. 1, 2, 3, 1, 4. Did any of those repeat? Yeah, sure. 1 repeated, so it's not a function. Remember? Guy 1 cannot date 2 different girls, so that is not a function. Alright? Now there's another way of telling if something is a function, is if you have a graph and you draw a vertical line anywhere, draw infinitely many vertical lines, and if any one of your vertical lines hits twice or more, it is not a function. Reason for that is this is like saying guy -1 is dating girl 1 and girl -1. So one guy is dating 2 girls. That's why when it hits 2 or more times, then it's not a function. So this one's not a function because you got the same point right on top of the same point. And this one's not a function because you hit it twice. Right? It's called the vertical line test. It's a very quick way to know if something's a function or not. So here, you can draw infinitely many vertical lines. It only hits once. Here, it definitely hits twice. Here, it looks okay, but look at 1. At 1, you're hitting there and there. So it is not a function. So this one passes, this one passes, does not pass, this one does not pass. It's not a function. Alright? You can set the viewing window on your calculator. They talk about that. Okay? If you want to look at your window of your calculator, that means what the screen is going to graph. You hit window. And notice there's 6 different things here, and after the Y scale, you don't care about these last 3. You just leave them alone. Okay? So you got X min, X max. That means the far left point and the far right point. And X scale is how far apart your tick marks are. Alright? And then you got Y min, Y max, and Y scale. That means how far down and how far up it goes, and how far apart each tick mark is. The most common mistake students make is when they ask you to type in a certain X min, X max, Y min, Y max, they forget to skip over the X scale, and they type their Y min where X scale belongs. Alright? So at this one it says type in -2, enter -3, 3, enter 0.5, and then -100, 200, and 50 is your scale. And now when you hit graph, it's going to graph what I had there before, but let me turn that off. So now if I hit graph, look at there, it shows X min is -2, X max is +3, and these are 1/2 tick marks. 0.51, 1.52, 2.53. And now it goes from -100 to +200, and each tick mark is 50. 50, 100, 150, 200. Okay? And so that's what your graph looks like. Okay? Now if you want to type in what they call a bunch of data, or a scatter plot, what you have to do is hit Stat, this button right here, and then you hit 1 for edit. And now you got to get rid of your old data. If somebody's used your calculator before, you most likely have data in here that you want to get rid of. So you're going to have to arrow up to L1 or L2 and hit clear, come back down, then arrow over and up, hit clear. Notice when you hit clear, the numbers don't go away until after you arrow down, then they do. Alright, so I'm going to type in these numbers from -2 to +2 by 1. So -2, enter, -1, enter, 0, enter, 1, enter, 2, enter. And now I arrow to the right, and I'm going to type in -2, 3, 2, and -3. Alright, now how do I graph this? Well, you first have to turn your plot on. So you hit second y equals, and you turn plot 1 on. Okay, you have to hit enter twice, and then second quit. Alright, so now if you want to see what your graph looks like, all you have to hit is zoom 9. Oops, let's try zoom 9 should work fine. Why isn't that working? Let's try zoom 6. Let's see if I screwed up on my data points. Stat 1. Oh, I didn't type in enough points here. I typed in -1, 0, 1, 2, -2, 3, 2, -3. Oh, this one doesn't have a 0, that's why. 1, 2, and clear. Oops, I'll have to clear that out and type them in again. -2, -1, 1, 2. And let's clear that out and type it in again. -2, 3, 2, -3. Alright, so now if I hit zoom 9, zoom 9 automatically gives you a picture with all of your windows there. You can't really see it too well because it's so bright. Sorry. But it shows you 1, 2, 3, 4 points. If you graphed it right, you'll see a graph with the 4 individual points. And that's what it looks like. That's what your window looks like. You got those 4 points there. Alright. So if you want to see what a graph looks like, you can graph something by typing in just y equals, and you want to turn your plot 1 off, by the way. Just go up to it and hit enter and come back down. As long as it doesn't have a black box around it, it's turned off. So 2x subtract 1. And if you hit zoom 6, it shows you a graph of your line. And if you hit second table set and start with 0 and go up by 1, if you hit second graph, it shows you your graph. And you can go into the negative numbers if you want as well. Okay, so what did we cover in here? We talked about a function, a set of ordered pairs where each input has a specific output. Okay, and there's several ways you can draw it. You can draw it by individual numbers, you can draw it with a formula, you can graph it, or you can use a table. Now the input variable of the function, that's your x value, and it's called an independent variable. Now your output is your y value, and that's your dependent variable. Now why is the y dependable? Because it's dependent on what x you choose. You choose a specific x, and then you get a very specific y. So the x is controlling this thing. Whatever x you choose dictates whatever y you get. Okay? And the domain is simply the x values, and the range is the y values. And then the vertical line test to see if something is a function or not. Alright, so we're going to do these problems here. And we do them in the exact same order. You're going to see them on the homework assignment. Okay? So question 123, it says determine whether s is a function. So it's a function if there's no repetition in the x's. So 1, 4, 7, 5, 2. 1, 4, 7, 5, 2. Nothing repeated there. So that is a function. Determine whether the phrase is a function, calculating the square of a number. Yeah, so each number when you square it gives one specific answer. You're never going to square 3 and get 2 answers. 3 squared is always going to be 9. 4 squared is always going to be 16. So that is a function. List the students who passed a given exam. Since a student either passes or not, there's only one answer for each student. So for each student, it's passed or that's it. So you'd have input is the student and output is the word passed. Or for input of the student, you wouldn't graph it to pass because they didn't pass. So Evaluate each one of these functions. So you plug in, you do f of blank equals 4 times blank minus 2. So you plug in minus 1 here and you multiply it out. Then you plug in 0 and you multiply it out. Okay? Then the same thing here. F of blank equals 5 minus 3 times blank. So you plug in minus 4 and multiply it out. 2 and multiply it out. And then f of blank equals 2 over blank plus 1. And you plug in minus 5 and positive 4 and you get your answer there. Okay, now it says use the table to evaluate the expression f of 0. That means x equals 0. So the y value is found underneath it at 5.5. F of 2, the y coordinate is 3.7. Alright, and so number 1.9, average precipitation, you've got P of 5 is 0.2. Okay, and part B says, is this a function of x? Well, for each input is a different input, 1 through 12, so it's automatically a function. It would not be a function if any of them repeated, but they don't repeat, so it's not. It is a function. Okay, and they ask you what's P of 0.4 represent? Well, month 2, month 3, month 7, and month 11 are all 0.4 inches of precipitation. Alright, write the function as a set of ordered pairs, given the function f of 1 equals 3, f of 2 equals minus 4, f of 3 equals 0. So 1, 3, 2, negative 4, 3, 0. Alright, and so your domain is 1, 2, and 3. Your range is minus 4, 0, and 3. X values are your domain, Y values is your range. Alright, so now this one says S of x equals 225x minus 450, So S of blank equals 225 blank minus that. So now you plug in 2009 into there and you get your answer. Okay, use the diagram to find the domain and range. So your domain is 1, 2, 3, 4. Your range is 5, 6, 7. That's it. 97, find the domain. Alright, do you see any fractions in here? Remember, when I say fractions, I mean a denominator with an x in it. No fractions, right? Do you see any square roots here? No. So it's all real numbers, or minus infinity to infinity. All you have to worry about is fractions and even roots. Square roots, fourth root, that sort of thing. Alright, so now multiply the input x by 5 and subtract 2 to obtain the output. So your function, your formula is 5x subtract 2. And when you plug in those numbers, you get these y values here. And I'd use your calculator to figure those out. And then you graph each one, and there you go, that's your graph. Now this one says find the domain. Well, do you see any fractions or square roots? Yeah, you see a fraction. So you worry about where x minus 5 equals 0. And if x minus 5 equals 0, that means x equals 5. So x cannot equal 5. So domain is all real numbers except 5. And you can write that out as well. You can write that out in this way. You can say minus infinity to 5 union 5 to infinity. Okay? That's the way to write it using interval notation. Remember, that's a union symbol. That is not a capital U. When you click on your answer box on your computer, off to the right should show you a template where you can choose union, intersection, and other things as well. Alright, this one says show what the window looks like on your calculator with these x min, x max, x scale, y min, y max, y scale, and it looks like this. Alright, now this one says find f of negative 5 and 3/2 for this guy. So f of blank equals blank squared, and you plug in minus 5 there and you multiply it out, plug in 3/2 and you multiply it out. Alright. Function A computes the square feet in x acres. So f of x equals 43,560 times x. So for each hectare, or for each acre, you multiply it by 43,560. So f of 10 equals that guy times 10, and you get this answer. Or in other words, 10 acres is equal to this many square feet. Alright. And now this one says f of I computes the inches in yards. So I of x equals 36x, so 36 inches in a yard. So for each yard you multiply by 36. And so that means 10 yards equals 360. It says find the domain. Do you see any fractions or square roots? No, all real numbers. Do you see any fractions or square roots? Yeah, you do. Now, when you have an even root like this, square root, you force what's underneath the square root to be greater than or equal to 0. And you solve that, And now this answer you keep. It's the exact opposite of when you're dealing with fractions. Remember, with fractions, you set the denominator equal 0, and whatever answer you get, you throw it out. With this one, you set what's underneath, greater than or equal to 0, solve it, and whatever answer you get, you keep. That is your domain. Alright? And then 61, they ask you to plug in 2 and minus 2, and you plug in f of blank equals minus 2 times blank cubed, and it's actually plus blank. I didn't do this right. I should have added 2 there, and so my answer should have been negative 14. And I should have added a negative 2 there, and so my answer should have been 14. Alright?